Hi guys, here's your video for lesson 9-3. Start off with our warm-up. Got a rectangle here and you might be thinking, why are we talking about a rectangle? This Pythagorean theorem is all about right triangles. Well, in the rectangle shown below, how long would a diagonal line be to connect opposite corners? Okay, so if I drew a diagonal line to go from corner to corner, okay, and we're asking how long is that line? Well, I see a right triangle. We all know that a rectangle has a right angle in the corner here. These would be my legs, my A and my B. And X would be my hypotenuse. So I can use my Pythagorean theorem, sub in, (3 squared is 9, 8 squared is 64. 9 plus 64 is 73. Square root both sides. And the square root of 73, not something I'm going to do in my head. We need a calculator. C equals 8.5. If I go back to the diagram, then I know that this is 8.5. Okay, so today's going to be a little bit different. It's going to be, we're going to solve for the leg. Okay, yesterday we solved for hypotenuse. Today we're going to solve for a leg. So what the problems are going to look like is this. Okay, when I use my highlighters, okay, here is my right angle in the corner here. When I use my highlighter, 6 is one of my legs, but X is now the other leg. So we're going to try to figure out what leg would go with 6. Oh, and guys, I'm so sorry. I have a typo here. This should be 10, not 100. So I apologize. Okay? Because 100 just doesn't make sense with the number 6. That's way too big. So the hypotenuse this time is actually a number, the number 10. And so we're trying to find a leg. So it starts out the exact same as yesterday. Whoa. Well, I guess there's nothing hidden there, so we'll have to write. Writing the formula, a squared plus b squared equals c squared. And then subbing in. Now, the 10 is my c, so I put that in first. The 6 and the x are the a and the b. I usually put the variable first. You can leave it as an a, you can put x, and I put the number in for b. So the number is b, the variable is a. Okay? Then I'm going to square my numbers. So x squared stays the same, but 6 squared is going to be 36. And 10 squared is going to be 100. Now here's where it gets different than yesterday. Okay, I want you to think about if we were going to be solving an equation. If I were solving any old equation and it was x plus 36 equals 100, we would subtract 36 on both sides. And x would equal 64. The only difference is x isn't just an x this time, it has a square to it. Okay, so we're just going to carry down an x squared instead of an x. So it says subtract both sides. So subtract 36, subtract 36, and I get x squared equals 64. Then we're going to take the square root of both sides. Square root of 64 is 8. I picked ones that came out nice for our graphic organizer. Okay, so let's do some examples. Let's use our highlighters first and highlight so that we're really clear about where's our legs, where's our hypotenuse. Here's the right angle in the corner. I'm going to go up and highlight the 9. Go back to the right angle, highlight across, highlight the W, so I can see that the W is a leg. Right angle. Oh, G is a leg. And 6 is a leg. Here's our hypotenuse. Our C is 14. And the C is 12. So the highlighting is going to really help, especially on tomorrow and your quiz on Thursday, because they're all going to be mixed up. So if you highlight, you know where your variable is. Well, did I just highlight a leg or did I just highlight a hypotenuse? And it helps you sub in the numbers in for the correct places. Okay? All right, so Pythagorean theorem, start with your formula. And sub in. So 14 is my hypotenuse. I usually put the variable in for a. You don't have to, but I do. Plus 9 squared. So W squared plus 81 equals 14 squared is 196. Subtract 81 on both sides. Let's see. How's my math at 6:30 in the morning? 115. Square root both sides. Alright, I know it's 10 point something. Let's see, square root of 115. 10.7. So that means if we go back up to the diagram, W equals 10.7. And this makes sense. You should always take your answers, go back to the diagram, and see if they kind of make sense. Are the numbers too big? Are the numbers too small? You know, certainly if I had stopped at 115, if I forgot to do the square root and I thought that this was 115 instead, so I've got 9 and 14, and 115 is way, way, way too big. Some people also try to do square root by dividing by 2, and that's not it. So 115 divided by 2 would be 57.5, and again, that's still way too big, 9, 14, and 57.5. So kind of look at your answer. You'll catch some mistakes that way if you find that the numbers are just way too large to go with the other numbers in the problem. Okay, and our last example on this page. Our C is 12. I always like to start with a variable. 6 squared is 36, and 12 squared, 144. So 144 minus 36 is 108. Square root of 108, 10.4. So in this diagram, we've got 10.4. And compared to the numbers of 6 and 12, they're all that's a reasonable answer. So the main thing I want to point out that's different than yesterday is this part right here, where I'm subbing in the numbers different places. Okay, one is a leg, one is the hypotenuse. And therefore, because they are on separate sides of the equal sign, I'm subtracting on both sides. Rather than yesterday, I would have added 81 and 196 because they would have both been legs and both been on same side of the equal sign. So that's the big difference from yesterday. Okay? Thanks a lot, guys. Have a good day.